And welcome. My name is Derek Harder, and in this video, we are turning our attention to looking at some other container types that Python has that are that aren't sequences that do have different purposes than just accessing a set of data in from beginning to end of the sequence. So, in particular, in this video, I'm going to be looking at the dictionary data type. So this is a very powerful data type. I find a lot of students, kind of beginning undergraduate, aren't too familiar with what dictionaries are. So we'll look at a dictionary, talk a little bit about what it is in this video, and then of course look how to use it and create them in Python. So if you're ready, let's go ahead and get started. So a dictionary is an object that stores a collection of data. So it's a container that stores a collection, like the lists and the tuples that we looked at. But each element in a dictionary has two parts. It has a key and a value. And basically, you use the key as sort of an index to locate a specific value. So to get a specific value out of the container, you have to know the key, and you ask to get the value or the data associated with that key whenever you want to read something back out of a dictionary container. So each element in a dictionary consists of a key and a value. And again, this is a common concept. You might run across a lot of names on this. These are referred to as maps, associative arrays, key value pairs, many other things, symbol tables, dictionaries. So in more modern high-level languages, it is common to have something like a dictionary data type as part of the language. These in languages, earlier like C or COBOL or things like that, you didn't really have these kinds of high-level containers. But this is a very common concept. So, like for example, if you're familiar with Java, I believe there's like a hash map, which is the same thing. C++ has what it calls a map, ordered or unordered maps. So basically, to retrieve specific value, you need to know and use the key associated with it. Okay, so and just a little bit behind the scenes, depending on how one of these maps is implemented, it takes pretty much like constant time, or at most like logarithmic time, which is still very fast, to read out a value if you access it by the key. Okay, so that's kind of very important. So maps or dictionaries are fundamentally random access. You can access, as long as you have the key, you can access any data in the same amount of time as you can access any other data. It's not like a sequential search. But I'll talk more about that in this video probably. So the basic format for creating a dictionary, so the curly braces are the syntactical unit in Python that normally mean that we're working with a dictionary data type. And if you want to initialize a dictionary, you use this notation where you give a key and then a colon and then a value. And if you have multiple key value pairs, you can have a list of these. Okay, so like a list in Python, lists of elements are always separated by commas, but for the Python dictionary data type, key value pairs are going to have this colon in between them to separate the key and the value. So elements in a dictionary are unsorted. In fact, they're indexed by the key. So you can't get items out of a dictionary in any particular order. They're going to be all jumbled up whenever you store them in a dictionary. So the general format for retrieving a value from a dictionary is, if you have a dictionary object, use square brackets. So it looks like you're doing an index, but instead of an integer index, you use a key. Okay, and I don't think I mentioned it yet. So the keys can be any immutable type. Okay, so like a string is immutable. It could be an integer index, so you can actually have a dictionary but use like integers as the keys. A tuple, you could use a tuple since that's immutable. So anything that's immutable can be used as a key into the dictionary. So if I can go back real quickly, this is referring to this dictionary here for the phone book. So if I wanted to access the phone number for the key Chris, I could do something like that. So this will look up the value in my dictionary for this particular key and return it from doing this read there. So when you access something, when you access a value using a key like this with the square brackets, if the key is in the dictionary, the associated value is returned. If it's not, you get a key error exception. Okay. So if you don't know if that key is already in the dictionary, either you're going to have to handle the exception, or I'll show in a second here, you need to check whether the key is in the dictionary beforehand. So you can use the in and the not in operators. So we ran across this for the sequence types. So those work for dictionaries as well. So this is a common idiom that you would do if you need to have a key and you're not certain yet whether it's in your dictionary or not. So you would just check if the key is in your dictionary. And if it is, you can go ahead and access it. And if it's not, you'd have to do something else. Like maybe you need to add that key or prompt the user to get the data for the value to insert the new key or something like that. Okay. So adding an element to a dictionary is pretty easy. Dictionaries are mutable, so they are actually modifiable. You can add new key value pairs, you can delete key value pairs from them, and you can modify an existing key to give it a different value. So you can do modifies or updates. To add a new one, the normal way you would do that is put the dictionary on the left-hand side and assign a new value into it. So this works both to add a new key value pair, and it also works to modify. So if this key Joe doesn't exist, so this is assuming the phone book dictionary that we showed initially being created. If this doesn't exist, it'll add a new key value pair, a Joe associated with this phone number. If it does exist, whatever the phone number or whatever the value was that was associated with Chris will be thrown away, and this will be the new value associated with the Chris key in the dictionary. So I mentioned you can delete. So dictionaries are immutable, so you can remove key value pairs. So the delete operator in Python is basically used to do that whenever you're working with a container type. So for dictionaries, if you want to remove a particular key value pair, you use the delete and you give it a valid key. Basically, you're doing a lookup, but you're asking it to delete that key value pair. If the key is not in the dictionary, you'll get a key error if you do this. You can also use the length built-in method for Python. So this will give you the number of key value pairs, so the number of entries in the dictionary that you have for a dictionary if you use the length here. So I probably covered all these already, but just to remind you, so keys need to be immutable objects, but the associated value doesn't have to be immutable. So any kind of object, immutable or mutable, can be the value. So the value could be a list, it could be an integer, a float, a string. A list could be a more complex data type. So often the values are going to be things like objects, or when we talk about objects and classes later on, we'll see how to do that. So it is possible to actually mix key types, although this is not a usual case. So often if you have a dictionary, all the keys are of the same type. Likewise, often if you're using a dictionary, the values are all going to be in the same type. But you can mix those, although I don't consider that usually a very typical kind of thing to do. So let's give just a few quick examples of creating dictionaries and adding and removing items from them. So stuff that we just talked about. I want to use something maybe a little bit more complex than the example that was being used in the textbook. So although I'm still using strings for the keys, but I mean you can use a list for the data types. Remember the value doesn't have to be immutables. It could be any value, including containers or even other dictionaries or things like that, right? So we just have a list of like an email and a phone number this time for our context here. So by the way, I don't know if I've ever mentioned this before, but I mean strings are actually immutable. They're another type of a sequence. So strings are sequences like lists and tuples, but they're immutable. So what that kind of means is that you can actually index a string. So if I have a string in with 3 characters in it, I can get the character at index 0, but you can't actually modify the string. So if I want to, change the name of the string, I actually have to create a new string with any modifications I make to an existing string. I can't modify a particular string in place. So, So I've got this dictionary called contacts with key value pairs. So let's see here. So we showed creating a dictionary. If you want to retrieve a particular value from a dictionary, you just give the key. So if I want to look up somebody in my contacts, I give the key, which are all strings in this case, and it will return back a value, which are lists from this dictionary here. Okay, so you will get, so case matters in keys. They have to match exactly. For string keys, Neo with a capital N is not the same as Neo with a lowercase n. So if you try to retrieve a key that's not in the dictionary, you will get a key error, and you can test that. You can catch that using an exception, although a more normal way when working with dictionaries is use the n. So we can check using the n whether Neo is in contact or not before we attempt to read that value. Okay, so if I want to modify an existing entry, we just give it a new value and something like that, right? So and this I'll just show that the types for the values don't have to be the same, although that can cause problems. So when you're writing code, the reason why that's kind of unusual, even though the textbook discusses this, is if you don't know exactly what the type is for every key value pair, you would first have to do something to check, okay, what is it that I got when I read this key back out before I can know how to use it, right? So anyway, if we modify that, I didn't do what I meant to do there. So this is a common error, but since I gave a misspelling of the key here, I actually ended up adding in a new item. So now we're going to see that we have Trinity in there, but we have Trinity as well, which is with just a string value. So let me show an example of using delete then. So I didn't really mean to do that. I'll just go ahead and get rid of that out of the dictionary. So this removes the key value pair in place for the key in the dictionary that I specify. All right. So now I'm back to having my three keys. So we can look at using the length. So this will give the number of key value pairs using the length built in for the dictionary that you give. So we've got three currently in our dictionary. So if I want to do what I meant to do, if I wanted to actually modify an existing one, you have to use an existing key. That should modify. So I should still have three values in there. But now my Trinity contact information just has a string value. So if you want to create an empty dictionary, just using empty, open, and closing curly braces works, like an empty, open, and closing square brackets if you want an empty list. And there is a dict method, so like the list and the tuple, there's a dict. You can use this to actually create a dictionary from other types if it can figure out how to convert it, or if you don't give anything to that, it will basically create an empty dictionary. So both common things. You can iterate over dictionary. So the default, if you're using a index controlled loop or counter controlled loop, is it will iterate over the keys. Okay, so if you do like this, the target variable for the for loop will be each of the keys. And again, the dictionaries are not in any particular order, so the keys will come out in some unknown order that you can't control or predict if you iterate over it like this. So let's just show a real quick example of iterating. So I still have my contacts with dictionaries with three contacts in there. So So if we iterate over that, we'll see that we're basically getting the keys out of there. And they came. So yeah, when you display context interactively, like I'm doing here, or if you print context, uh, these aren't going to be in the order that we initially inserted them into the dictionary, so they'll be kind of mixed up. But I believe that the order that they get displayed out like this would be the order that you would see them, if that matters. But usually that doesn't matter. Usually you won't know what order you get things in. So and it is common, since you're iterating over by the keys. That we can use the key to access the value inside when we're iterating over it, if we need to do something with every value, right? So again, the basic idea of a dictionary is, it's not meant to be accessed sequentially. So iterating over, needing to do something with every item in the dictionary is not as common as iterating over like a sequence container. But you do have to do that. For example, you still want to do this typical kinds of applications. So one application, like doing a report over all your content, like having a display of all the contacts in your dictionary, you would have to iterate over the dictionary in that case. So here, I mean, my info is just lists of things, but so I believe we can just, this will print out the list here, even using a formatted string like this, if I remember right. So there, I'll just look up the key in my contacts and also put that into my print statement. So yeah, the print, or the formatted print, knows what to do with lists. Just displays them as lists or strings. So I have one of these is a string now at this point. So like we talked about before with lists and tuple, a Python dictionary is a container. So it works as like an object. So it's an instance of an object. That means that you have methods. So a lot of the more advanced stuff that you can do with a dictionary, you would call a member method, invoke it on your instance of a dictionary. So these are some of the ones. I'll just look at a few of these kind of real quickly. So you can clear out the contents of a dictionary. Instead of getting it using the square brackets, you can get the value associated with the key. This does something slightly different. So this can be useful if you're not certain if the key, another way, if you're not certain if the key is in there, that it will return a default value if the key is not found. You can get all the keys and values as a tuple, but you can also just get all the keys or just get all the values. And you can pseudo, I probably should have talked about this for a list, but like lists, dictionaries, you can kind of pseudo treat it as like a stack and push and pop things onto it. So, I'll remind again about the standard library documentation. So you might want to use that. So in particular, again, I'll just show this again. If you go to the documentation, you should find for all the built-in types, including in this video, we're talking about the mapping types, the dictionary here. So this is another way to look at the member methods that and the operations, the built-ins or the built-in operators that you can do things with dictionaries. So let's just real quickly look at a couple of those methods. So I've got an instance of a dictionary object called contacts. So, for example, here are the member methods anyway that you can do. So the things that we just saw, like the clear, copy. We didn't have that one on our list. Get the keys and the values and the items. So the easiest ones to understand are something like contacts dot keys. So this will actually return a list of the keys. It returns something that's iterable. So it's a little bit, it's not exactly a list, but you can iterate over it. like that, right? Same for values. So if you need to iterate, so that's really doing the same thing. It's just iterating over context. It's just really doing the keys, right? But if you wanted to, you could iterate over the values instead. If you don't really care about or need the keys, you know, to iterate over everything and just do a report. All right. So that just gets the values. So items returns a key value. It actually returns a list of tuples. So you get each item in the list is a tuple, where the first item in the tuple is a key and the second item is a value. If you do items. And I'll just show one more example, the get method. So this is often useful in lots of contexts if you're working with a dictionary and you're not certain if a key is in a dictionary yet or not. So you can specify a default value to use if you do an attempt for a key and that key isn't there. So if I do a context.get on Trinity, and we specify a default let's say a default string as the value, right? So since Trinity is in there, it will get that, and it will get the I invoked that incorrectly, so it's actually not a keyword argument. So you just pass in two parameters. The default is just none if you don't specify this, but if you want to, you can specify a default. But in this case, Trinity is a key that's already in my dictionary, right? So it actually looks it successfully found it. But if you do this instead of getting a key error for a key that's not in there, like something like this, if it's not in there, you'll get the default instead if you do a get. So this can often be useful. And okay, finally, I'll just go ahead and also mention dictionary comprehensions quickly here as well. So, you know, all the container types in Python allow this kind of alternative syntax in order to create the container. So if you understand how they work, then, you know, kind of guessing what the syntax would be to do a comprehension on a list or a tuple or a dictionary in this case usually makes sense. So a dictionary comprehensive is an expression that reads a sequence of input elements and uses those input elements to produce a dictionary. So it's similar to list or tuple comprehensions. So here's two examples. Let me kind of just show these two examples, work these interactively here. So I'll just make a list of names from my current contacts that I have. So an example of using the keys method here, but I turn it into an actual list instead of the kind of the dictionary key type that you get back from there. So, you know, to do a dictionary comprehension, we can do something like, basically it's the curly braces because we're working with dictionaries, and then it's a key value pair, so item and then like the length of the item, and then we have something that's really a for loop, kind of for loop statement. So for item in names, for example. So now name length is actually a dictionary where the keys are my original names and the values are just the length, the string length of each one of those. So now, and kind of like we talked about for lists, you know, the you have to be careful when you're working with references to dictionaries, because this doesn't actually make a copy. Context2 is just a reference to the same one, right? So now if I change contacts, so we'll change Neo's value to be a different, just a string again here. But since context2 is really just a reference when we did that, both of these will be pointing to the same dictionary. Right, so you see they were both updated. So if I really want to make a copy, you can. I would actually use the copy method. Like that. Now, so now context2 is all the key value pairs were actually copied. So if I make a change in contacts now, just some other string here. Like that. This updated my key value pair for the Neo key, but this should have been a copy. So this was what it was when we originally made the copy. So, but you could use a dictionary comprehension to do a copy like that. So currently now my contacts have these values. If I want to use a comprehension to make a copy, just another example of a dictionary comprehension. So here's an example of using the items member method, right? So this is going to return all the key value pairs, right? So it iterates through all the items, returning a list of key value pairs. So if each one of those key value pairs, we just insert that back into our context2 dictionary using this comprehension. Right. So, and again, this would be an actual copy because of the way this works. Although, like I said, I wouldn't do that personally. I would just use the copy method if you need to make a true copy of a list or a dictionary or something instead of having a reference to it. All right, so that's it for our discussion on dictionaries. So, just to summarize what we talked about in this video, a dictionary is a collection or a container object that stores key value pairs. You can look up items using the dictionary keys. So the items in the dictionary are indexed or hashed by the key to make it efficient to retrieve or read a value associated with a key that's stored in a dictionary. You can add or modify items in a dictionary by reassigning the key to a value. Or assigning a value to a key that's not already in there. You can use in and not in operators to test if keys are present or not in a dictionary. You can use the delete keyword, like we showed for other containers, to remove key value pairs. Dictionaries are collection objects, so they're actually an instance of a dictionary is an instance of an object, so it has member methods. Some of the useful ones that you might use a lot are like the get, or the items, or the keys, or the values are the ones I use most commonly myself. So, and dictionary comprehensions are available, like comprehensions for most any other container type in Python. Probably, I think all the container types in Python, you can do comprehensions like this. So you might run across those, so it's good to know, be able to understand what's happening if you see that examples of those in the syntax. Okay, so that's it for this video. I hope these videos are useful for you. Let me know if you have any comments or things. I'll have links to any things I talk about in the video descriptions, and that's it. Hope to see you in the next video or see you in class.